Welcome to Work It Out Wednesday. I'm going to give a couple minutes for a few people to join, and then we are going to kick this thing right off. Welcome, Jace. We're so happy to have you tonight joining us. And we did get your problems, and you are going to be the first one that we kick it off with tonight. And yes, welcome back as well. Alrighty, I am going to go ahead and get started tonight. And as others join, they can jump right in. So we have a problem submitted for simplifying using prime factorization. So it looks like here, and I just wanted to start off with this one. Even though it looks like they could have gone a little further, just so that we all can see what's happening here. So we're simplifying this fraction, but we're using prime factorization to help us to know what goes here and here, and then what is the fraction that we end up getting. And so I'm going to tilt my camera just a little bit more in case you can't see it. So we put our 48 and our 120, and we're using our factor. So we know 6 times 8 gives us 48. And then when we talk about prime numbers, we know that our prime numbers are any numbers that are only divisible by 1 and that number. So 2 is prime, 3 is prime, 5, 7, and so on. So we know 6 can be broken up into 2 and 3. And since those are prime numbers, we stop there. And our 8 is broken to 2 and 4, but 4 is not prime. So we can keep going, and that is how we break it to 2 and 2. And then what we will do with these prime numbers here, and I'm just going to put a dot so you can follow me. Where it says 48, that is what is going to go at the top of this tile. So it should say 2 times 2 times 2 times, and they're missing 3 here. So I'm just going to put that there. Okay. And then so now we're going to do the exact same thing for our 120. So they did 4 times 30, which is correct and great. And we know 4 is not prime, so it breaks down to 2 and 2, which are both prime, and 30 into 6 and 5. And actually, for this example, I know the student probably just started this. I would switch and put my 5 here because the 5 is prime. So we don't need to factor it anymore. And the 6 is not prime, so we need to factor it. And so since they already have our factorization bubbles there, that means that's where we need to go. So we will put a 2 and a 3 here. And so just like our other one, we're only going to take our prime numbers. And this time I'm going to mark it with a green since I wrote in so much black. So a 2, 2, 2, and 3 this time is going, oh, oops, I missed it. And our 5 is going to go in our fraction bar here. So our fraction bar here should say 2 times 2 times 2 times 3 times 5. Not sure how well you can see that, but there should also be a 5 there. And then our next step, one of my favorite parts, is now that we have the prime factorization on both the top and the bottom, or our numerator and denominator, we're going to cancel these things out. So 2 and 2, 2 and 2, because these are 1. And we have enough of each on each side. 3 to cancel. Hold on. 1, 2, 3, 1, 2, 3. There's something missing here. No, this needed an extra 2 as well. That wasn't there already. So what happens is we cancel out with the same numbers, and what we're left with is a 2 and a 5 that we're unable to cancel out. So that gives us our reduced down 2/5. And so this one was already started for us. So we're actually going to do a whole nother one so you can really see what is happening each step of the way. As a matter of fact, let's go to this one first because it hasn't been done as much. And it should make some more sense to us. And I will write in black so that we can see well. So this time we have 16 over 24. And so let's first start with our prime factorization again. So we know 16 is 8 and 2, which is really great here. And we can break down our 8. What could we break down 8 to? Not 4 and 4, right? Instead, what two numbers multiply for 8 that we can break down? Can somebody drop it for me in the chat? 4 and 2, that's correct. So we're going to change that to a 2. Well, we know 2 is prime, but is 4 prime? No, it's not. So we can actually extend that. So we would get 2 and 2 for our 4 again. And then since this 2 is already prime, you do not need that bubble. So Jace, since you're on here, I just want to ask, are you building these yourself? Are you building the models out as you're doing the problems? And you could just type it in the chat for us to let us know if you're building the models. Okay, well, when he comments, he will, but we'll keep going. So we know that 24 is absolutely 8 times 3 here, and 3 is prime. Yes, you're building the models. Okay, so you're going to want to fix on your models, okay? Because you don't need that one at your 2, and you do need to build some more on that 8. So, okay, I totally get it now. All right, and so I would switch this 8 and 3 because we know that 3 is prime, so we don't need to build it out. So let's scratch those and let's switch them. So this one's going to be 8, this one will be 3. And now we know that 8 breaks into 4 and 2. Oh, and see, I did that myself. But we know 4 still needs to be broken down because 2 is prime, so we'll do 2 and 2 here. And then just like the others, we are only taking our prime numbers. So we are keeping this 3, the 2, 2, and 2. And for this one, we're keeping 2, 2, and 2. And so over here, you're correct with your 3 2s up top. And then for 24, it's 2 times 2 times 2. And then we also need to add times 3 here. And a good question, and just to make sure we understand, you can check if your prime factorization is correct by actually multiplying the prime numbers. So we know 2 times 2 is 4, times 2 is 8. So that means we need another 2 here, right? And 8 times 2 is 16. So that's how we can check. And you know what? That's because I'm miscircling our 2 up here. That's how you can make sure that you have the correct prime factorization. So same here, 2 times 2 is 4, times 2 is 8, 8 times 3 is 24. So we know that our prime factorization is right. Just like we've always done, you always want to check your work through your different steps just to make sure you have it right. So now that we know it is correct, now we are going to cancel out. So we have 2 and 2 here. So that's 1. 2 and 2 here. That's 1. 2 and 2 here. So anytime we have a fraction and we have the same number up top and bottom, that cancels out to be 1. So that leaves us with 2/3, which will actually be our answer to reduce this problem. or simplify. So 16 over 24 is equal to 2/3. So I'm going to give everybody a minute. Are there any questions? Does anybody want to drop a question in the chat about how to do these problems? Or was there a step you didn't understand? And Jay, since you're on here, is there any parts of these steps that you didn't understand? And I will give you all a minute. As well as, would you like me to work one more of these before I move on to the next topic? Type it in the chat for me. Yes, please. Okay. I will work one more for you. All righty. Let's do this one here. All right. So we have 60 over 72. And we have 60, which the student put 20 times 3, which is good. But again, we want to switch the numbers. So we're actually going to put 20 here and we're going to put 3 here because 3 is already prime for us. So we know we need to break apart that 20. Can anybody drop in the chat what 20 can break into? What two numbers? Let me get some help to make sure everybody's understanding. What multiplies by each other prime that gives us 20? 10 and 2. That's good. Okay. Anybody have another one that they want to drop in the chat? 5 and 4. That's another good one. So we know, let's go with 5 and 4. And you notice I put the 5 here because it's prime. It's not going to factor anymore. So I put 4 here because we do know that's going to factor. And we know our factors of 4 are 2 and 2. But you could have absolutely done this with 10 and 2 as well, because 10 is going to break up to 5 and 2. So either one works. All right, so now we are going to do the same with 72, which the student has, right? 8 times 9, good. 2 and 4, and the 4 breaks down to 2 and 2, and 9 is 3 and 3. So perfect. We are ready to actually do our prime factorization. And I'm going to use red this time so y'all can see. So our prime numbers are 3, 2, 2, and 5 for our top. So right here, we already have 2, 2, 3. We need to add our 5. And then on our 72, it is 2, 2, 2, 3, 3. So that's 3 2s, which we have. And now we need to add 2 3s. So 3 times 3. Hopefully y'all can see that. And so again, we are now going to cancel out what equals 1. So we have 2 and 2, 2 and 2. And then now we have 3 and 3. And so this time at the top, yes, we're just left with 5. But at the bottom, we're left with 2 and 3. So we are going to multiply those together, which gives us 6. So 5 over 6 is correct. All right. And are we clear what being a number being prime is? It is a number that is only divisible by 1 and itself. So that means we cannot break it apart any further. So there's no other multiples is really what we're saying here. So the multiples of 4 are 2 times 2 and 1 and 4, whereas the multiple of 2 is just 2 and 1. So alrighty. I hope this has helped tonight. I hope you have a really great understanding. And Jace, as always, thank you for joining us. We really appreciate you being here. And I am going to move along to some other problems tonight. Alrighty. Let's head on over to a third grade problem that was submitted. So we did middle school. Let's do us a third grade problem. And we just all love a good word problem, right? All righty. Lennon used all the lollipops in 5 packages to make goodie bags for a party. There were 9 lollipops in each package. Which equation can be used to find the total number of lollipops Lennon used? So, just like anything, we use the method called cubes as one of our strategies for solving word problems. And it stands for circling our numbers first is the C and their units. So we have 5 packages and we have 9 lollipops. So circle our numbers and we underline any of our keywords. So Lennon used all of the lollipops in the bag to make goodie bags, and we would underline in each package. I go ahead and say each package because it's telling us that we're multiplying here for sure. So now we want to box our question. Which equation can be used to find the total number of lollipops? So we're looking for what's going to be that equation that's going to help us find our total number of lollipops. And so this is a great problem to draw a picture really quick. So we know there's 5 packages, 1, 2, 3, 4, 5, and there's 9 lollipops in each package. And so we know, well, if I have a 9 in this one, and each time I'm getting 9 more, I'm absolutely multiplying. So we can already eliminate B and C because we are not multiplying. Now, D might have been something because it's absolutely possible because you're getting bigger because it's going 9 plus 9 plus 9, but it only did 3 nines, whereas we have 5 nines. So that is what makes A the only reasonable choice here for this problem. All righty, and we are going to continue. I actually like this problem up here, strip diagrams. Our strip diagrams are everywhere, and we like our students to know them when they see them. And it says, write an equation that matches the strip diagram. So first, we have to figure out what this question is asking us. So one thing about our strip diagram, let's talk about the parts of it. So usually we have a total. So this number here with the question mark, it's looking for the total. And then where we have these 11s here, those are the parts. And our parts always equal our total, just like an equation does. In an equation, our 2 sides have to equal each other. Same with our strip diagram. The total is going to equal whatever your parts are. And hi, Gwen. Thank you for joining us tonight. If you have any problems, you can drop them in the chat, email them to help@Math-A-Matics Tutoring. We look forward to you participating tonight. Thank you for joining us. All right, so we have our total and we have our parts here. And we're trying to see, how can we make an equation out of this? Well, one, we see that 11, it's repeating, right? And we know that repeating numbers here, we can either add them, or with this particular topic, we're working on multiplying. So we can absolutely multiply. And we know that we have 4 boxes. So 1, 2, 3, 4. So we are doing 4 times, well, 11 is what is repeating, 11. And we want to know, what does that equal? So that's our equation that we've come up with from this strip diagram. So we know 4 times 11 is equal to 44. And so that is how we can use that strip diagram to create an equation. I'm going to do one more of those strip diagrams just because I know it is a tricky one for our students. And this is a 3rd grade assignment, by the way, in case anybody was wondering. So Noah has 24 fish. The model represents what he did with the fish. And so there we go again, our strip diagram. So that 24 is our total. And what we're looking for this time are our parts. What are our parts? Based on the model, which of these could explain what Noah did with the fish? He put 24 divided by 3 fish into 3 tanks. He put 24 times 3 fish into 3 tanks. Or he put 24 minus 3 into 3 tanks. Well, we know that we're looking for the same number in each tank, and we already know 24 is our total. So since we know 24 is our total, 24 times 3 would give us a bigger number, right? Because that's 3 sets of 24. So it couldn't be that. And because we know our total is 24, if we subtract 3, we won't get our total. So it can't be C. So it has to be A, which is true because our total will remain the same, but we are cutting the parts into 3 equal pieces. And so that is how we can use our strip diagram and really visualize and talk through our answer choices as well when we're choosing something. It's so important to justify why what is happening as well. Alrighty, and we are going to continue. So I am going to jump to a subtraction problem that we saw. So we saw this subtraction problem, and it was 50 minus 29, and it has certain steps of how it wants you to do the work. So 29 is what we're starting with. And so we're actually using addition to get back to what is our subtraction problem. So we know 29 plus 20 gives us 49. And 49 plus 1 gives us 50. And then we could do that 20 plus 1, we're adding them together, equals 21. And so those first 2 steps got us back to 50, which is the number that we are subtracting by, or the number we really wanted to get to. And so we know what got us there because we started with 29. What got us there was 20 and 1. So that's how we know that 50 minus 29 is equal to 21. So this is a different approach to the subtraction, but it's using the addition and making it into things that are easier for students to actually add. So we know it's easy to add with 0, right? When we have a 0 in our ones place. And we can all add to 1 because that's just the next number. So thinking about that. So we're going to do an example. I wanted to show you all this one before I tackled another one. So we're going to keep that one in mind as we work this one together. So just like the other one, we're going to start with that 41. Okay. So 41, and then let's think about it. What can we add that will get us close to 80, but not quite to 80 or over 80? Well, in my mind, I'm going to say, well, what if I added 40, right? Just half of that 80. Well, no, because 40 plus 41 would give me 81. So instead, I'm going to go ahead and add 30 because I want it to be something that will be manageable. So our ones is 0, so we know that's going to be a 1, and 4 plus 3 is 7. So that'll be 71. So we're going to put 71 here now. And our goal is to get to 80. Well, we know, we're making a 10 with that 1 now. So we know that 9 and 1 make a 10, which would give us 80. And so now what got us to 80? Well, it was adding 30 to 41 and adding 9 to that 71 that we got. So now we're going to do 30 plus 9, which actually gives us 39. And that gives us our answer. 80 minus 41 is equal to 39. And I know some are probably like, oh my gosh, that is a lot of steps. But it definitely challenges our number sense, our problem solving, getting comfortable with making tens. And these are a lot of the new math strategies that our students are accustomed to. So it's definitely something to practice for sure. Someone wants me to go over the tree strategy. Could you go over the tree strategy for greatest common factor? Okay, yes, we can. Let's switch gears. Do we have a number that they would like me to do for the tree strategy for greatest common? In the chat? Anything? Okay. Well, no worries. I will make up a number. Alrighty. So let's do, she said any number would work. Okay, perfect. Thank you so much. All right, so let's do 30 and 20. And we are talking about, we're doing greatest, yeah. Okay, so we are going to use 20 and 30. And so we're looking for the greatest common factor. So what that means is what is in common between these two numbers and what is the greatest number that is in common between the two numbers, okay? So first we're going to factor both of these numbers. So we know that 30 we can do 5 times 6. And this goes back to if you were here at the beginning. If you weren't, we'll just repeat it. This goes back to using our prime factorization to help us. So we know our prime numbers are like 2, 3, 5, 7. Any number that is only divisible by itself and 1. So we know 5 is prime, but 6 is not. So we're going to break that again into 2 times 3. Okay. And now once we've broken our numbers into our prime factorization, we're only now thinking about the numbers that we got that are prime. So 5 times 2 times 3. Those are the prime numbers for 30. So now let's do the same thing for 20. So 20, we can go ahead and do 10 and 2. Well, we know 2 is prime. We know 10 breaks down to 5 and 2. So now that's all the way factored. So 5, 2, and 2 will be the prime numbers for here. So I'm going to write it 5 times 2 times 3. Now, how we actually find our GCF, as it's called, our GCF, the greatest common factor here. Oh, I made a mistake. This is supposed to be a 2. Okay. Is what numbers or which factors are in common for both of them? Well, they both have 5. They both have 2. This 20 has a 2 and this one has a 3, so we won't count that. And then you multiply those factors together. So 5 times 2 and 5 times 2 is 10. So our greatest common factor for 20 and 30 would be 10. Any questions? And would you like me to share another one? I'll just do another one just in case. Let's do one more. And feel free if the person wants to shout out some numbers, I'm fine with that as well. So this time, let's do no questions. All righty, thank you. All right, let's do 36 and 28. So 36, 28. All right, so we know, and actually I'm going to let the audience tell me, what times what gives me 36? All right. Thank you, whoever from Instagram. We appreciate you participating tonight. All right. 6 times 6 gives us 36. I'm so sorry. 6 times 6. All righty. Well, those are not prime. So we know we can break each one of those into 2 times 3 and 2 times 3. All right. And all 4 of these numbers are prime. So now those will be the only numbers that we will focus on. So that'll be 2 times 3 times 2 times 3. All right, now let's do the same for 28. Can anybody drop in the chat what times what gives us 28? Seven times 4, good. Or 4 times 7, either way, same thing. So 7 times 4. And we know 7 is prime already, but 4 is not. And we know 4 is 2 times 2, which they are all prime as well. So we're going to circle our 7, we're going to circle our 2, we're going to circle our 2. So we are left just focusing on 2 times 2 times 7. And so the same thing, now we're looking for our GCF, our greatest common factor between those numbers. And again, it's only what's in common. So 2 and 2, 2 and 2 are in common. So our greatest common factor here will be 4. All righty. Thank you so much for that question. And we are going to keep moving tonight. Thank you for participating. We really appreciate it. I hope this was helpful in understanding how to do GCF. All righty. We are going to keep moving tonight. Feel free if anyone else has any questions or needs us to explain anything, we will be happy to help. We did a little bit of 3rd grade tonight. Let's hop on over to 5th grade. And we have a multiplication with decimals. I just love decimals and multiplying, don't we all? So I'm going to do this one here. It says, find the product of 3.2 and 4.5, or 3 and 2/10 times 4 and 5/10, just so that we are using proper math vocabulary too. So when we're multiplying by decimals, I like to line up the numbers by the decimal place. Money absolutely uses decimals as well. So that's like $3. And I would add a zero to both of these. So 20 cents and 50 cents. Well, one thing we are supposed to do when we're multiplying decimals, we can go ahead and just kind of move those decimals to the back, and we'll remember them later. So I like to say 1 DP, and DP for me stands for decimal point, and 1 DP. So both of these had 1. So that means I need to move a total, because we're going to add those together, of 2 decimal points when I finish multiplying. And I just like to use that acronym DP because it just stands for decimal point. You're more than welcome to use whatever works for you. So now it feels more comfortable, because really it's like multiplying 32 times 45. And I'm probably going to multiply the old school way tonight. I know. There's so many ways to multiply these days. So 5 times 2 is 10. So we're going to do 0 carry 1, which is 15, plus 1 is 16. And then we're moving to our next place value, the tens place. So that means we're not starting at our ones place. So we're always going to put a placeholder 0 there. So now we do 4 times 2, which is 8, and 3 times 4, or 4 times 3 is 12. So 2 and 1. And then our next step is to add those together. And we get 0, 4, 2, 3, 4, and a 1. And then that's when our DP comes back into play. And we always start from the back, because there is actually an imaginary decimal point back there. For every number, there is an imaginary decimal point behind that ones place. So we're going to go 1. We're going to go 2. So our answer is 14.4. And we could keep the 0 if you want to. So it could be 14.40. Or it is okay to even leave it without. Any questions on that? Let's do another one. Let's see what we have here. Okay, I like this because it is a whole number times a decimal. Miss Robertson ordered 15 pizzas for a party. Her guest ate 0.75 of the pizzas, or we can say 75 hundredths of the pizzas. What amount of the pizzas were eaten? Alrighty, so we are going to multiply to figure out what amount was eaten of these pizzas. So we're going to do 15 times 0.75 this time. Okay. And this time we only have one number with our decimal point. And this is also a placeholder 0. So we don't even really have to show it. So I'm even going to rewrite this totally. But our 0.75 here, we know that's 2 places behind. So I'm just going to write a 2DP over here to remind myself that later I need to move this by 2 decimal places. So, okay, we're going to really do 15 times 75. Is how we're going to write it, because we're going to keep it comfortable for ourselves. And we've already noted that we have to move these decimal places anyway. So now let's multiply. So 5 times 5 is 25. And we're going to carry that 2. 5 times 1 is 5. Plus 2 is 7. We're going to that tens place, so we have to put our placeholder 0 here. 7 times 5 is 35. So 5, and we're going to carry a 3. 7 times 1 is 7. Plus 3 is 10. We're going to get a 5, 12, 1, and 1. And we already know we need to move our decimal points twice. 1, 2. So 11.25, or 11 and a fourth, or we could say 11 and 25 hundredths of the pizzas were eaten at the party. Sometimes decimals can feel totally intimidating, but when we break them down, we can, when we break those decimals down, we can make it simpler and make it something that's a lot more digestible for us. So a student is getting some problems. Talk to me in the chat. Are they still coming with their problems? Am I waiting on them to do our next problem? Let me know, Kimberly. Let me know in the chat, just so I know where to go. I will wait. I don't mind. Okay, while we wait, if you were here earlier, I mentioned cubes for word problems, and we have I don't even know why I'm going to mess with this, but we have a strategy guide that has those strategies just already drawn and written out for us. So it is a great, useful tool, and it's something that I use as a go-to, and we use with our students as a go-to. Integers, please. Subtracting integers. Okay, that is a fave. Okay, let me think of some numbers on the spot, which, I mean, that's fine. I just, let's see here. Let me get a fresh sheet of paper out. Okay. So one strategy, and I'm going to say it, hopefully you can hear well. Same sign, add, different signs, subtract, and change to the sign with a bigger number. That is what I use when we are adding and subtracting integers. So I'm going to do a few examples of integers to see if those are the ones that you're needing or you're needing support in understanding for sure. And I'll use that strategy that I just said as we work on them too. So say we have a -7 minus 11 is equal to something. Ooh, I wrote that a little crooked. Please excuse that. So technically they have the same sign. So what I mean by that is we have a -7, and this minus sign here is taken on by our 11. So since we have the same sign, we're going to add those together. So what's 7 plus 11? Well, that's 18. And since they're the same sign, we're going to keep the sign. So now we have a -18. It just got more negative. Now, if I said instead we have 4 minus 6, well, 4 is positive here, right? Because there's no negative sign. So the 4 is positive and the 6 is negative because it takes on that minus. So they're different signs. So now we're actually going to subtract, and you're going to subtract it like regular. So you're going to subtract it like 6 minus 4 because 6 is the bigger number. So we know that's 2. And then now it gets the sign of the larger number. Well, 6 is larger than 4. And it's really the absolute value of the number. So if we did the absolute value of -6, it's 6. So 6 is the larger number. And since it has the minus sign or it's attached to it, it becomes a -2. All right. And then now one more example that gets friends always tripped up. Well, actually, I'll do two more. So we can have -5 minus a -2 equals. Well, we know when we have a negative next to a negative, I teach my students, circle that, and we're going to change that to a positive now. So now we have two different signs because we have a -5 and we have a +2. And we know, and you see it in the chat here for you all, different sign, we're going to subtract. So we're really doing 5 minus 2, which we know is 3. And then it gets the sign of the larger number. Well, 5 is bigger than 2, so we're going to get -3. All right, and then I'm going to do one more for you like this. So say we had 7 minus a -4. All right, well, again, we have a minus and a minus, so we're going to circle those and turn it to a plus. So now they're actually the same sign because they're both positive now. So that's really 7 plus 4, which will be 11. Partial quotients to divide, please. All right. Oh, we working tonight. I love it. So let me hear. I know this is coming via Instagram. Can I hear from my Instagram person? Did the integers subtraction, did that make sense? Did you need me to work another? Those are typically the 4 examples and ways you're going to see it. And then if so, I will kick to the next person problem just based on what you say. I'm going to give them maybe one more minute. For my person with partial quotient, do you have a problem in mind? Or do you want me to just make something up? If not, I will make something up so that we could keep the party rolling. Okay. All righty. All righty. This is Work It Out Wednesday. We are here every Wednesday. Every Wednesday. We may be not here next week because we have something, but every Wednesday we are here. Okay, 168 divided by 14. All righty, thank you so much. Let me get this started. All righty. So we are going to do all righty. So partial quotient division, it's breaking it apart really using place value, okay? And so we're doing things like 1, 10, 150, things that are numbers we're more comfortable with. So when I have my students do partial quotient, you can make something up but 4 digits. Oh, you want 4 digits? Okay, no worries. Let's add a digit. I don't know if this is going to be divisible, but that's okay too. We're going to just add another 8. Okay. All right. So let's make a T-chart. I like to make a T-chart on the side so that we are already comfortable. Now, you do not have to make a T-chart on the side, but it can help you for sure. All right. So over here, I'm going to make us a quick little T-chart. And so we're multiplying by 14. So we know 1 times 14 is 14. Okay. 2 times 14. Well, we know we could just add 14 plus 14, which would give us 28. Then I like to do the 5. So we know that 5 times 4 is 20. So we have a 0. And we're going to carry our 2. 5 times 1 is 5 plus 2 is 70. And then I like to do 10. So 10 and 14 times 10. Well, we know anything times 10, we're just really giving it the 0. So it's really 14 and we're adding the 0. So 140. And then I'm going to take it a step further. And we could have even done that because now we have 1, 2, and 5. We could just add zeros. So now I'm going to say 10, 20, and 50. And so all we're going to do is say 28 because that was what was times 2. And we add a 0 behind it. Same for our 5. So we had 70 for 5. Well, now we're just going to add a 0. So now we have 700. And then we're going to go to 100. So that's going to be the same thing as our 1 and our 10. So if you use 1, it's 14 and you're just adding 2 zeros. That way, we have a range of numbers that we can use to help us with our partial quotient. All right, I'm just going to give you a minute to look at that to make sure that you understand. And then you can start anywhere. Since 1400 is our largest here, and that's times 100, that's where I'm going to start so this doesn't get too long. And it's just a great place. So we're going to put 100 on our outside here. And then this 1400 is what we are going to subtract here. So that gives us 8, 8, and 2. So now we're at 288. So we'll look at our thing. Well, the closest number would be 280. So now we're going to put 20 here. And we're going to subtract 280 from here. And we'll get 8. And those are zeros. So we get 8 left, which is smaller than 14. So that's actually going to be our remainder. So we're going to add these two together. So that gives us 120. So our answer will be 120, remainder 8 for this problem. And that's how you do division by partial quotient. Would you like me to do another one? Does that make sense? And if you want to know if you can do this without making a T-chart, you absolutely can. For partial quotient, you want to use numbers like 10s, 50s, 100s, because it's about using the zeros to help you break that number down when you may not be as strong with your math facts. Because we know anything times 100, we're just adding 2 zeros behind that number. Anything times 10, we're adding 1 0 behind that number. One more, please. Got you. All right. The only thing I don't like about these, I'm not that great at picking numbers off the top of my head. I will say that. But let's think of something. What do we have? Because you told me a 4-digit. Let me see. Somebody else said one more. I got you all. Let me get me a number. You said a 4-digit number. Okay. Oh, something. Multiple. Oh, okay. Alrighty. Getting a new sheet of paper here. If you've been here before, if you haven't been here before, we're still working out what our best way to show problems are to everyone out there. And, I feel like I'm wasting so much paper. I feel so bad for using all this paper, but I might have to figure out something else so that I don't go through some paper sometime. um, but I also really like writing by hand versus technology. I'm just a little old school like that, but we'll figure it out. We'll figure it out. Yeah, save the trees. You're right. All right. So again, partial quotient. And I think of this, like a little hangman because it just gives you room to write. So this time we're doing 9, and I'm going to do it again by that T-chart. It's just a great way. You don't have to think too much. Well, I mean, you kind of do, but so I do 1, 2, 5 to start. Well, we know 9 times 1 is 9, and we know 9 plus 9 is 18. And then we know 9 times 5 is 45. And so even if you ask me what if a student or even yourself, what if I don't know, what the 2 is, you already know that you can count up to that. And even for the 5, if you don't just know that 9 times 5 is 45, you could go 5, 10, 15, 20, 25. That's why we choose those, because they are easy for us to get to when we may not know our multiplication facts really well. So now we're going to do 10, 20, and 50. So we're literally taking these same 3 numbers, 9, 18, 45, and we're just adding a 0 behind each because that's all that happened. And we could do this because of place value. You can test that on your own. Let's go to 100 here. So same 9, we're going to add 2 zeros. If we wanted to, because this, I can already see this is going to be a lot because this number is 6,673, which is fine because y'all need to see me repeat a couple times anyway. Let's go to 200 and let's do 50 as well. So it'll be the same thing. So it'll be 18 and it will be 2 zeros, and then it'll be 45 with 2 zeros as well. And I'm going to move it up just so you can see. Okay. Then what we can do, we can start on this one with 500, or if you just wanted to do it like multiple times, you could absolutely start with 100 and you would just keep subtracting. But I'm going to start with 500 because that's our biggest number right now. And we're going to subtract it by 4,500. Alrighty, so that will be 3, 7, 1, and 2. All right, so we have 2,173. So I'm going to go back to this chi chart, 1,800. So that will be 200. So now we are going to subtract that 1,800. We get 3, 7. We're going to come to our neighbor, 3. So we're at 373. We're going to go back to our chi chart, 20 will be up next. And we're going to subtract 180. And you see how that preparation is just helping us slide through this. So we get 3. We're going to cross out our 2, 17. 17 minus 8 is 9. 2 minus 1 is 1. So we are at 193. So again, we're going to do 20 more. And we're going to subtract 180 again. And let me slide my paper up so you're following. And that was why I made my line so long this time. So we have a 3 and we have 1. So we have 13. Well, this time we can keep going. Well, we know that goes 1 time. And we're going to subtract 9. And we know 13 minus 9 is 4. All right. So 4 is going to be our remainder because it is smaller than our 9. So there's nothing else we can do. So now we are going to add these up based on place value, 500, 220, and 20. So we'll get 1, and then 2 and 2 is 4, and 5 and 2 is 7. So our answer is 741, remainder 4. All righty. So that is dividing by partial quotient. It's quite a few steps. Takes some thinking, but it is a great way until you build your multiplication skills, and it really helps you understand what is happening in this thing called division for sure. Well, alrighty, we are here every Wednesday for Work It Out Wednesday for 1 hour, usually about 7 to 8 o'clock. We have been streaming live from YouTube and Facebook, and today we added Instagram, and we are just so happy for you all being here. You can email your questions ahead of time to help@mathematicstutoring.com. We get those questions and we come here live and we work them out for you for free 99. Shout out to everyone that joined. Tell a friend next time. Bring somebody with you. We are happy for you to be here and to be a part. Follow us, like, and share for sure. We are always doing problems and different strategies on our social media channels. So even on Instagram, the people watching us on Instagram, we have this partial quotient division problem. We have 2 videos over it on our Instagram. So even if you want to see that again, you can watch the videos on our Instagram showing how you do this as well. All righty. Thank you so much again for joining us, and we will see you next Wednesday. Have a good night. Oh, I'm so glad this made sense to your son. Thank you so much for tuning in. We really, really appreciate it.